Alright, in this video we're going to use the addition and multiplication properties of equality to solve linear equations. That's what we're focusing on. Let's first take a look at what an equation is. By definition, as I referenced in an earlier video, an equation is two algebraic expressions separated by or connected by, let's even say that, connected by an equal sign. An example you'll see below, the expression x squared minus 9x is connected to the expression negative 8 by this equal sign, making this an equation. Our main focus with these equations is to solve for the variable, the unknown variable. So we should talk about what a solution is. A solution to an equation is the number or value of the variable that you could substitute in, and that will give a true statement. So as we look at this equation below, just to kind of explain that solution piece, if we were to substitute 2 in for x, and solve, we have 2 squared, which is 4, minus 9 times 2, or negative 18, and that equals negative 8. 4 minus 18 is negative 14. Negative 14 does not equal negative 8. This is a false statement, and therefore not a solution. If we were to substitute the value 8 in for x, eight squared is 64, negative 9 times 8 is negative 72, and 64 minus 72 is negative 8. That equals negative 8. This is a true statement. Therefore, 8 is a solution. If we were to solve equations by just picking random numbers and substituting them in, trying to find the true statement, trying to find which would be the solution, that would take forever. So we have several steps and methods and properties that we're going to use to be able to solve equations more efficiently and effectively. What we've done here, however, is given an example of a check. Once you believe you have an answer, always substitute it back into the original equation, as I did here, to see, did you do your calculations correctly? Does the answer that you believe, the solution that you believe is the answer, is that really the answer? This check will help you do it. And in this case, we know that x equals 8. We're going to focus our time in this first video looking at linear equations in one variable. So there's going to be a single variable, for example, x in the last, or in our first example, and then we're going to have no exponents other than 1. So everything will be raised to the first power, unlike the example we just worked through. A general form of a linear equation is going to be ax plus b equals c, where a, b, and c are real numbers. We begin looking at how to solve these linear equations in one variable using two basic properties. First, the addition property of equality. Second, the multiplication property of equality. And that will be the focus for the rest of our video. If A equals B, then A plus C equals B plus C. Basically, we can add or subtract something to both sides of an equal sign in an equation, and we will not change the value of that equation. We will change its appearance. For example, you today are still the same person that you were yesterday, but your appearance is slightly different. You might be wearing different clothes, or maybe you got a haircut, or something. But you're still you. The same thing here. The equation will still have the same value. We're just changing its appearance, and there will be advantages and disadvantages to doing, to adding or subtracting, depending on the equations that are given. So we'll take a look here at this first example. My objective when solving a linear equation is to make sure that I get all of the variables on one side of the equal sign and the constants on the other side. So I'm going to simplify each expression individually. So x plus 3, that does not simplify any further. But 7 plus 8 does simplify to 15. I can add them together, so I'll do that first. And now the addition property of equality we will use to get x by itself. We're going to subtract 3 because 3 minus 3 is 0, leaving us with just x. But if I'm going to subtract 3 on the left side of the equation to keep it balanced, I must subtract 3 from the right side, leaving us then with 12. Of course, we can check by substituting back into the original. 12 plus 3 equals 7 plus 8. 12 plus 3 is 15. 7 plus 8 is 15. And therefore, it checks, and x equals 12 is the answer to this equation. In the next example, again, we want to get variables to one side of the equal sign, constants to another. I'm choosing to put the variables on the left here because I recognize I'm going to have to subtract 4x from both sides of the equal sign. And when I do that, I'll be left with a positive x. If I can make that positive, I will do that always. X equals 16. Letter C. 7x minus 5, that is already simplified, equals 8x plus 10. This also is already simplified. So again, we want the variables on one side and the constants on the other. In this case, I'm going to choose to put the variables on the right side and the constants on the left side, because I'm going to subtract 7x from 8x, which will give me a positive x. Plus 10 equals negative 5. We now have the variables on the one side of the equal sign, but the constants are not exclusively on the other. See, I still have a 10, plus 10. So we're going to subtract 10 to move this term. And so negative 15 equals x. And we could check again. 7 times negative 15 minus 5 equals 8 times negative 15 plus 10. 7 times negative 15 is negative 105 minus 5. And 8 times negative 15 is negative 120 plus 10. When you subtract 5 from negative 105, we get negative 110, and negative 120 plus 10 is also negative 110. So this checks, and x equals negative 15. In letter D, we have some simplification that can take place early. 10x minus 5x, I can subtract that, which leaves me with 5x. The 4x minus 11 expression cannot be simplified any further, so we'll go here. I would typically choose to put the variables on the left side. Well, I'm going to do that here as well, actually. Variables on the left side, constants on the right, because I want x to be positive. So if I subtract 4x from both sides, I find out that x equals negative 11. You can substitute this in and we'll find that it does check. But for sake of time, I'm not going to go through the check again here. Letter E. This time we have the distributive property we recognize here. We have to distribute 2 to x and 6. So we'll have 2x plus 2 times 6, which is 12, equals x minus 3. At this point we have simplified the expression on the left side. The expression on the right side of the equal sign already was simplified, and so we work to get our variables on one side, our constants on the other. I will subtract x. So x plus 12 equals negative 3. We will subtract 12. X equals negative 15. This also will check when you substitute back in to the original as I've modeled for you before. Letter F. This time we have simplification in both expressions to work with. 3 will distribute to 4x and to the negative 11. 3 times 4x is 12x. 3 times negative 11 is negative 33. We will distribute negative 11 to the 3 as well as the negative x. Negative 11 times 3 is negative 33, and negative 11 times x is positive 11x. We need to get our variables on one side of the equal sign and our constants on the other. So I will subtract 11x from both sides, bringing the variable over here. 12 minus 11 is x. Minus 33 equals negative 33. We're going to add 33 to both sides, so that way we bring this constant to the right, leaving the variable by itself here. And we have to add 33 to the right side as well, keeping this equation balanced. And negative 33 plus 33 is 0. X equals 0. In each of these examples, we were left with 1x every time. But what if there's a coefficient of x, or a number in front of x? How would we isolate the variable in that case? By using the multiplication property of equality. In this case, just like before, if a equals b, then we could multiply by some value both sides of the equation, again changing the appearance but not its value. So I could multiply by c, some number, as long as it's the same number C on the right side and the left side, we're good. This also works for division. Example A is a one-step equation. It's similar to what we might have been left with in the last 6 examples if there was a number other than 1 in front of x. We see 7 times x here, and we want to use the inverse operation. The inverse operation of multiplication is division, so we divide by 7. Again, keeping that equation balanced, both expressions divided by the same value. 7 divided by 7 is 1, and now we have that magical 1x. And 35 divided by 7 is 5. Example 2b is a little more complex. There seems to be 2 expressions that both can be simplified. 5x plus 6x, we can do that addition and simplify to 11x. 39 plus 5, they're both constants and like terms as well, so we can add those to get 44. At this point, we are left with the variable on the left side, where we'll keep it. The constants we want to move to the right side. This 11 needs to go away because we want 1x by itself. 11 times x, so the inverse operation is division. We divide both sides of this equation by 11. 11 divided by 11 is 1. X equals 44 divided by 11, 4. Letter C has several steps in simplifying first, before we ever would get to the multiplication property of equality. First, we see the distributive property, and so we will distribute the negative 16 to the 1, as well as negative x. The negative 14x is outside of the parentheses, so that will not be multiplied by negative 16. Just what was inside the parentheses. Negative 16 times 1 is negative 16. Negative 16 times negative x, positive 16x. Again, because a negative times a negative is a positive. The negative 14x comes down unchanged, and that equals negative 10. We're going to continue simplifying the left side of this equation by combining like terms. The negative 16 stays, but positive 16x minus 14x, those are like terms. We can combine them to get positive 2x equals negative 10. At this point, we will use the addition property of equality that we spent time with earlier in this video. To get 16 over on the side of the equation where the constants will go, and we'll leave the 2x here on the left with the variables. So we will add 16. Again, addition is the inverse operation to subtraction, and if we add to the left, we need to add to the right. 2x equals 6. At this point, we see 2 times x. We'll use the inverse operation of multiplication, again, which is division, to divide both sides of the equation by 2. X equals 3. Example D. 5x minus 4 equals 26 plus 2x. In this case, there are no, or the expressions on both sides of the equal sign are already simplified. There's nothing that we can do to kind of clean that up, and so we will work to get the variables on one side of the equal sign and the constants on the other, as we did in the addition, using the addition property of equality. So we are going to add 4 to both sides, and we'll have 5x equals 30 plus 2x. And now we have variables on both sides, but the constants are only on the right. So we'll move 2x by subtracting, since the inverse to addition is subtraction. Subtracting 2x from both sides of the equal sign. So 3x equals 30. At this point, we have multiplication left, and I want x by itself. So we will divide both sides of the equal sign by 3. 3 divided by 3, 1. So x equals 30 divided by 3, or 10. Letter E has several things that can be simplified. Again, let's combine like terms right away. 8x minus 5x is 3x plus 3 equals x minus 7 plus 10. That simplifies to plus 3. I would like the variables on one side of the equal sign, the constants on the other. We'll subtract x from both sides of the equal sign. So 2x plus 3 equals 3. We subtract 3 to move the constants to the right. 3 minus 3 is 0. 2x equals 3 minus 3 is 0. That's interesting. And at this point, don't be confused. We still will operate using the same process as we have in the previous examples. We see multiplication, 2 times x. We need to use the inverse operation and divide by 2, because our goal is to have x by itself. And if we divide the left side of the equation by 2, we need to divide the right side of the equation by 2. 2 divided by 2 is 1x. 0 divided by 2 is 0. Letter F. We have several simplification steps to take care of here before we ever get to the addition or multiplication properties of equality. -2 will distribute to the 5x and the -1. -2 times 5x, -10x. -2 times -1, +2. And again, we will not multiply -2 by the -x, since that was outside of the parentheses, so we'll just leave -x right there alone. On the right side, we have to distribute 4 to both terms inside the parentheses. -4x plus 12. On the left, we can simplify further by combining like terms. -10x minus x is -11x plus 2, and that equals -4x plus 12. We'd like to move the variables to one side of the equation and the constants to the other. So let's start with variables. Add 4x to both sides of the equation. Again, -4 and +4, the subtraction and addition are inverse operations, and therefore will add together to be 0, leaving us on the right side with just a +12. And on the left side, -11x plus 4 is -7x, and the +2 will come down. We should add 2 to both sides, or subtract 2 because again, inverse operations, we want the 2 to be on the right side of the equation. And so negative 7x equals 10. We now have the constants on the right, the variables on the left, except the variable term again has a coefficient of negative 7. In order to get x by itself, we use the inverse to multiplication, which is division, and we divide both sides by negative 7. And our final answer, x equals negative 10 sevenths. This video is just a basic introduction to solving linear equations in one variable, as we've looked in isolation pretty much at the addition property of equality, followed then by the multiplication property of equality. In the next video, we'll look at putting all of this together with some even more complex equations to solve.